Okay, so here's an example of graphing parabolas using a lot of the properties we know about parabolas now. And first of all, we want to mention the fact that f of x, remember this is a rule, and it's actually the rule that gives me the vertical position of any point on the graph if I'm graphing this, and this is given my independent variable x being put in here. So this is the x, the horizontal position, and this whole thing gives me the vertical position. So sometimes we could also call this y, because y we use the vertical position. In other words, our points are usually x, y. X is the vertical position, the horizontal position, excuse me, and y is the vertical position. And we could say x, instead of writing y, we can write f of x. It's the rule that gives you the vertical position. This is the rule. Something squared plus 6 times something plus 5. And that something is coming, that's our independent variable that's coming from the domain. And the whole thing, this value, is the range, or part of the range. Okay? So we can also write this as y equals x squared plus 6x plus 5. Okay, so first of all, we're going to write this, we're going to want to graph this parabola. So first of all, we're going to put it in vertex form. Makes it nice. So we'll go back to the f of x notation. And I'll put the x squared and the 6x by themselves, and then I'll put the 5 over a ways. And I'll try to create a perfect square trinomial. So the square root of x squared is x. Half of 6 is 3. And what's 3 squared? 9. So I'm going to add 9. But since I was on the same side, I also have to subtract 9. So I'm basically just adding 0 to the right side of this equation. And we know that this is going to factor to be a binomial square with this sign positive. And these numbers go here. X and 3. And if you square x plus 3 times x plus 3, you get that. Then over here we've got 5 minus 9 is negative 4. And now we've got this in vertex form. And we can see what the vertex is right here. The vertex is negative 3 and negative 4. Since this is positive, we know it's going to be shaped like a U or open upward rather than downward. And what we're going to do now, in order to graph it, well, we can analyze this also. We know we have an axis of symmetry. That's just going to be, this is the x and this is the y. It's real easy. It's just going to be x equals negative 3. Since it's shaped like a U, it's going to have a minimum. And that's going to be at y equals negative 4. So the minimum will be negative 4, or you can say y equals negative 4, or at y equals negative 4. This is a line. The axis of symmetry is a line. Okay? Now we can, when we look at the graph, we'll be able to see if we've got zeros or not. So let's take a look at this and let's graph it, what we've got so far. So we know we've got the vertex is at negative 3, so I've made a graph over here. So it's negative 3, negative 4, so negative 3, negative 4 is right over here. So there's our vertex. And our axis of symmetry is the line y equals negative 3. That's a vertical line. So this is the axis of symmetry. That's going to help us a little bit later. So there's your axis of symmetry that goes like this. Let's see that. All right. Let's make it a little wider there. So that's our axis of symmetry. And now we know it's down here, so we know we're going to have two x-intercepts or two zeros because it's open up and it's below, the vertex is below the x-axis, so it's got to cross twice. So we know we have two roots, but we can actually find the roots, or the zeros, because the zeros are going to be when the y value is 0. So I go back to this form. Y equals x squared plus 6x plus 5, and we want to find out what value of x will make that 0, so we just set that equal to 0. And we're going to find our zeros, or our x-intercepts. And we can factor this. And factoring is the method you always try first in quadratic equations because it's usually the easiest. This tells me these signs are the same, and this tells me they're both positive. So this tells me these signs are the same, and this tells me what they are. So they're both positive. Only one way I can get 5, 5, and 1. So I know that x plus 5 equals 0. so x equals -5, or x plus 1 equals 0, or x equals -1, and those are my zeros, or my x-intercepts. So I can put those in, -5 and -1, so -5 is over here, and -1 is here. And that makes sense because they're both 2 units on either side of the axis of symmetry. All right. Now we can also find the y-intercept. That's the y value when x is 0. So when x is 0, and we could think of a little table of values here, x, y. When x is 0, if I put 0 in here, y equals what? Well, y equals 5, because 0 plus 6, 0 squared plus 6 times 0 is 0, so we just have y equals 5. So that's how we find the y-intercept. That's where it crosses the y-axis when x is 0. You see x is 0 here, so we can put that in. X is 0, and y is 5. And this is what we call the y-intercept. So the x-intercepts are going to be at -5 and y is 0, and -1, 0. So those are the x-intercepts. And then the y-intercept, we only have one of these, y-intercept. Is going to be when x is 0, and y is 5. That's the y-intercept when x is 0. The x-intercept is when y is 0, and the y-intercept is when x is 0. So we can put that point in. Now once we have that point in, we know we have an axis of symmetry. This point is 3 units to the right of the axis of symmetry, so I know I have to have another point 3 units to the left. And I've got, looky there, I got 5 real nice points, so I can graph this parabola. And try to make this make this as rounded as you can at the bottom. And there's your parabola. Y-intercept, x-intercepts, or zeros. Now, since we have 2 x-intercepts, we also know about the discriminants. That's another thing we can say. What's the discriminant? That's the part that's under the radical in the quadratic equation. And since we have 2 real roots, that must be positive. So we can also say that b squared minus 4ac must be greater than 0. Just so you know, because we have 2 real roots. All right, so do we have a minimum value? Now, we talked about the minimum value. You can see the minimum value is at -4. That's the value. Remember, value is the vertical position. We can also talk about the domain and range. What's the domain? Well, you can see that this is going to go, it's going to keep going out and out and out. So it's going to be -infinity to infinity. And what's the range? Well, I've got a low value of -4, so I'm going to start at -4. We usually go left to right, and that's a bracket because it can be equal to -4. That's my minimum value, and it's going to keep going up and up. Sometimes we put little arrows here to indicate that the parabola is going to keep going up and up to infinity, and that's always an open parentheses, or an open interval, excuse me. Parentheses means an open interval. So there you go. We got this really nice graph. And look at all these things we can tell just by this, analyzing this one equation here. All these things we can find. Okay? So let's think about that. We'll look this over. There's a lot you can tell from that one equation.